In this lecture, we're going to learn about constexpr. And this is a mechanism we have in C++ to do conditional compilation of our code. Let's look at a simple example to really drive this home. Suppose we have two functions, one that works really well for double types and another that works really well for integral types. And we want the users to be able to use these functions through a function template that we set up in our code. So we can do something like this. We can set up func as we do here. It's going to be a function template. You see our template parameter here. And inside, we're going to say if the type is integral, if the type they call this function with is an integral type, I want you to generate a template instance using the integer version of our function here. And we're going to call func integral. If they call our function with something that is not integral, we're going to call the floating point version of our function. And we can really do this. We can say if constexpr, this is the syntax. We're going to check if what they pass in is an integral type using a type trait. We already know how to do this. And we're going to call the int version of our function. We can say else if constexpr, what they pass in is a floating point number, then we're going to call the floating point version. And if neither of these cases are true, we're going to hit this else block here, and we're going to say this function can only be called with either integers or floating points. And you can do something like this. The beauty about this is that the branches that are discarded by our if statements here are not going to be included in our template instance. So this is really going to make our code easier. We're going to remove things that are not going to be used in our template instances. And this is going to be really cool. I realize some of this might be cryptic for now. We're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is constexpr. We're going to grab our template files and use them in our current project. We're going to put them in. And we're going to open this in Visual Studio Code by dragging and dropping on top of Visual Studio Code like this. So this is going to open our folder. We have our main function here. We can close the left main and do some cleanup. And we're going to include our type traits library. Let's do that. Okay, this is in. I am going to go ahead and put in my functions because I don't want you to watch me type all this because it is really easy to see. Now we have two functions. One is working on floating point, the other is working on integral types. And we're going to be just printing that the function was called floating point func and integral func. Let's say that. Let's make it super clear which function was called here. So we're going to say floating point func. We can copy the name actually and put that in here. No need to do some complicated things. And we're going to say the name of the function. We should say called, for example, to make it super clear that it was called. Let's do that. And we have a function template, which is going to dispatch calls to our two functions here, depending on the template argument we call func with. And this is all done at compile time. I really want you to see this. In other words, this is going to be done in the process of generating your application binary. And this is going to discard the branches that fail our test here. So for example, let's go in the main function and put in a few function calls for this guy. We're going to say func, and we're going to put in a 12, for example. Okay, so let's try and go through what happens when this function is being compiled. The compiler is going to look at the call we have here, and it's going to see a function template. It's going to see that what we are calling with is an integer literal. So it's going to go in here and see if constexpr is integral. This is going to be true. And we are going to run this block here. We're going to set up to call func integral because that's what we want to do here. But the funny thing is, or the interesting thing, I should say, is that now that we have found the correct branch in our if statements here, the other things are going to be discarded. In the template instance that is generated by the compiler, only func integral is going to be included, and we're not going to have the junk that we don't really need in the template instance. Let's run the program first to show you that this is actually calling the integral version of our function. Then we're going to head over to CPP Insights and show you that parts that are not used are discarded. You see the output says func integral was called. If we change this to be a double integral, let's do that. This is going to hit this check here. So is floating point is going to be true here, and we're going to activate this call. And all other things that are not needed are going to be discarded. And we're going to say func floating point called if we build and run this. So let's build again to really show you this. And we're going to clear and run rooster func floating point called. And if we try and pass in something else, for example, let's pass in a string literal, say hello, for example. And this is not going to work because the first check is not going to go through. The second check is not going to go through. We're going to hit the last one and we're going to do a static assert, which is going to fail. And we're going to print this message here. Let's try and build this program. And again, all these things are happening at compile time. I really want to stress this. We're going to have our static assert, which is going to say, we have a compiler error here. It's not the error we expected, but let's try and build again to make sure you see the static assert fail. And now it's going to say static assertion failed, argument must be integral or floating point. We have hit this guy here because our function was not called with an integral type or a floating point type. Let's turn this back to int because it's easier, I like it. And we're going to copy this code here and take that in CPP Insights and really see what is happening. Okay, we're going to take out whatever was in there and we're going to put in our function. And now we want to see the function template instance, which is generated by the call here. But before I hit the run button, I want to go through this with you. The compiler is going to see the call we do here. It's going to see that the guy here is an int literal. So it is an integral type. It is going to go in our function here and I'll run the if statements here. The first guy here is going to succeed because it is an integral type. 12 is an integral type. And we're going to activate this call here. So the template instance, which is going to be generated by this call, is going to include the call to func integral here. And the interesting thing again is that all other things that are not needed, for example, all this code we have here after the func integral call, we're not going to include that because it's not needed in our function template instance. And that's really cool. Our template instances will only contain the things that are needed for the function call. So let's hit the run button and really prove this. This is going to go through CPP Insights. And when it's done, we're going to get the output here. And now you see it is done. We have our functions. If we go down, we're going to have our function template, but we want to see what the compiler generated. And here is our function here. And here you see that it is going to be a template instance for int. This is the way CPP Insight shows you this. But if you go inside, you're going to see that we don't have all the branches we had in our if constexpr statements here. We only have the one that succeeded and which is going to call integral type. And this is what we have here. And this is really cool. The template instance is only going to contain the things that are needed for that branch that succeeded in our if-else blocks here, which happens to run at compile time. Let's change the call here to make it double. We're going to make it, for example, 12.8. And what this is going to do, the compiler is going to see that this guy is a double literal. It's going to select this branch here that calls func floating point, and the others are going to be discarded. Let's try to hit the run button and really see this. Okay, CPP Insights is good. We can go down and see the template instance, and you see that in our function here, we just have this branch. And everything else that wasn't needed is not going to be included. We just have what this function template instance needs. And this is really all I wanted you to see. And this is one of the things you can do using if constexpr. You can choose branches to run at compile time, and things that are not needed are going to be discarded, making your function template instance really optimal. Okay, this is all I had to share in this lecture. I hope you have a better view of what you can do with if constexpr. And I hate to say it, this happens to be the last lecture in this chapter. So we're going to stop here in this one. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.